Hi everybody. Today I'm going to explain you the acid-base theories. So let's get started with a couple of acid-base theory, guys. So firstly, let me get started with the Arrhenius theory. Okay, Arrhenius theory of acid-base. Theory of acid-base. Clear? So according to Arrhenius, what he talked about the acid and base. So he said that acid is a substance. Acid produces hydrogen ion when dissolved in water. Okay. And then he said that base is a substance that produces hydroxide ion when it dissolves in water. So base basically produces which ion? Hydroxide ion when it dissolves in the water. Alright. Basically, the acid produces hydrogen ion and the base produces hydroxide ions. Let me take one examples for the acids. So let's take examples here. Now if I write here HCl, so the HCl is called hydrochloric acid. So when hydrochloric acid is dissolved in the water, it produces hydrogen ions and chloride ion, guys. So as it is producing H plus ions, so therefore we consider HCl is a acids. However, if I take these examples, guys, you can have a look. Here we have NaOH. Alright. So NaOH also, if you dissolve in the water, they will separate into different ions and they will form Na plus and OH minus. That means when you dissolve the metal hydroxide here, sodium hydroxide, you're going to get hydroxide ion, guys. Therefore, this compound is known as base. Okay, or this is also said to be alkali. However, HCl is an acid. Alright, this is based on the Arrhenius theory. How about the theory of Bronsted and Lowry? Okay, so this theory was not valid for all the compounds. Why? Because there were some limitations. So let us understand about theory of acid base by Bronsted and Lowry. Okay, so what they said about acid and bases. So basically, in fact, when we talk about ammonia, NH3, ammonia is a gas where you cannot have oxygen. So how do you get OH minus ion? How it will produce OH minus ion? That is the question. So when ammonia gas is being tested, we came to see that this turns red litmus paper into blue. Red litmus paper turns into blue color. So that means it is a base. That last class I told you how to identify acid and base by means of litmus paper. Yes or no? So that is why the Arrhenius theory was not valid for ammonia. This theory was not fit to the ammonia. So what they said, Bronsted and Lowry said that they simply said that acid is a substance which is proton donor, and base is a substance which is proton acceptor. Alright. So what is the meaning of proton? Proton is basically means just hydrogen ion, guys. Alright. Proton means just simply hydrogen ions. So now if I take examples to describe in which compound you can see there is a transfer of hydrogen ions from the acid part. So let us take some examples to understand how it will be done in the protons. Alright. So if I take examples of hydrochloric acid, the same examples I have taken for Arrhenius also. So if you react hydrochloric acid with water here. Okay. Now we came to learn that based on the Bronsted and Lowry said that acid is a substance which can donate proton. So can you see in hydrochloric acid there is hydrogen. So this hydrogen will be donated to the water. So when this hydrogen is transferred to this water, so here H2O was there, now it will become H3O plus. Okay, now what is the left one? The chlorine, Cl minus. That means hydrogen is donating, hydrochloric acid is donating hydrogen ion to water, so therefore it will act as an acid. Okay, so this is called proton donor. Proton donor. Alright. However, as water molecule is receiving, accepting that hydrogen, so it is known as, it will be act as a base as per Bronsted because it is accepting. So proton acceptor. Understand? So this examples is valid. However, if you take the examples of NH3 and react with water here, now you can see, we know here water will act as an acid here because from the water hydrogen will be donated to the ammonia, therefore NH4 plus ammonium ion will be formed and hydroxide ion. Alright, so this condition is satisfied. So Bronsted-Lowry theory of acid base was accepted because it was satisfying, the ammonia was satisfied. That ammonia is receiving, accepting the hydrogen ion, accepting the hydrogen ion from water, therefore it will act as a base. So ammonia is as